We are going to rotate this one 60 degrees counterclockwise. So that's a positive 60 degrees is our value for theta. We have a tensile stress on the what I'm going to call y, also a tensile stress on x, and we have our shear stress state up and to the right here of 75. Again, we will rotate it 60 degrees counterclockwise in this case. We want to identify our original stress state from our original picture. We have tensile stresses on x and y, as I just said, so those will both be positive. So positive 150 megapascals in x, positive 100 in y. And what's the value of our tau xy? Right, positive 75 on the what I call positive x face. It's pointing in the positive y direction, so that is also positive. We're going to take this, we're going to rotate it 60 degrees counterclockwise. Right, so again, we want to be careful of what we're calling the new x prime face, what we're calling the new y prime face. It was originally here. I'm rotating it now counterclockwise 60 degrees. So this is my new x prime direction. This is my new y prime direction. And this is 60 degrees apart. Again, identifying the new prime faces is crucial because otherwise you can easily switch where the normal stresses are acting. And you would say that the x was acting on the y face and the y on the x face. So make sure you're paying attention to the direction of that rotation to identify the new faces. Right, same equations that we were just using, which are pretty straightforward, plug and chug. So in this case, we have 150 plus 100 over 2, plus 150 minus 100 over 2, times cosine 120, plus, now we do have to consider we have that tau xy that is non-zero, 75 sine 120. Putting all of our values in, we'll get a positive 177 megapascals for sigma y prime. Basically the same equation, but subtracting the second and third terms. But we also get a positive 73 megapascals. And for tau xy, negative 150, or negative 150 over 150 minus 100 over 2, sine 120, plus 75 cosine 120. So the tau x prime y prime, this is where we get a negative 59.2. We have our three new stresses. Now we want to map those onto our picture, same way we did in the last one. On our new x face, a tensile 177. On the new y face, also a tensile, but 73. And here, at least compared to our original picture, we flipped the direction of our shear stresses here. This is in a negative shear stress state. So again, if we go to a positive face, for example, this is our positive x prime face, it should be pointing in the negative y prime direction. So positive x face, negative y prime direction, because that's down to the right is negative y prime. And that determines the direction of all of our shear stresses with a value of 59.2.